These two videos show two pieces of cardboard being dropped in different orientations to see how that affects the rate of descent, the rate of acceleration. So on the one on the left, we see both objects dropped parallel to the floor so that there's a large surface area from each of them which can come into contact with the air as they fall, and we'll see what happens. Let's watch that in slow motion. They kind of crisscross at the end, but they accelerate at just about the same rate. You can see as they fall down together, pretty much the same. Then they sort of each cross over, nice little effect, and hit the ground at about the same time. They both have the same mass and the same surface area, so they feel the same force of the air as they fall. On the other hand, if we look in this situation, one of the objects is twisted so that there's much less surface area. Let's see what that looks like. So at this point here, we can see that this object on the right presents a very large surface area to the oncoming air as it falls, whereas this one only presents this very narrow strip here, which means less air can come into contact with it, and the acceleration should be much greater. So let's take a look and see what that looks like. And let's watch that again. And we can see that as they fall, it's really no contest. The one on the left accelerates at a much greater rate. Here's the horizontal one and the vertical one. And as it falls, it twists a little. But even at this instant here, when it's just about on the floor, this one is much higher. So simply changing the orientation of the objects as they're falling so that one presents a much smaller surface area to the oncoming air reduces the effect of the air, and it accelerates closer to what it would actually in a vacuum.